Now we're going to work a few more problems from the Chapter 5 exam review, starting with number 5. We have been given the values that we need to use for log base 3 of 4. Don't use your calculator. It'll give you a more exact answer than this. Not that it's exact, but a better approximation than this. Don't use your calculator on this. You need to use the values that you're being given. So we're not trying to use our calculator to get this value or to use for these two. We have to use the values that they have given us, these approximations up here. So log base 3 of 52, and we can only use things that we got to figure out how to get to 52 using 4 and 13. So let's go with 52 is 4 times 13. Log base 3 of 4 times 13, and remember the properties of logarithms that tell us that means we want log base 3 of 4 plus log base 3 of 13. And so log base 3 of 4, we're supposed to use 1.262. For the log base 3 of 13, we're supposed to use 2.335 as our approximate value there. And so that means that we're going to get 3.597 for our final value. Let's look at part B. Let's use the properties of logs to split this into two different logs. This would be log base 3 of 13 minus log base 3 of 9. Now, log base 3 of 13, they've given us. We don't know, we aren't being given log base 3 of 9, but if we remember that this just means we're looking for the exponent we put on 3 that gives us 9, then we can realize that's a 2. So this one, we're supposed to use the approximation 2.335. For this one, we need to subtract 2. When we subtract 2 from 2.3335, we get 0.335. And so the answer that we would get using the approximation they gave us is 0.335. On this one, 16 would be 4 squared, so we can turn this into log base 3 of 4 getting squared. And now we can use the property of logarithms that says bring that 2 to the front. We will have 2 times log base 3 of 4. And so that means we will have 2 times our approximation, 1.262. And when we double 1.262, we get 2.524. So this is the approximation that we will have for our answer. Now on this one, let's use the property of logs that says addition goes with multiplication. Let's bring that one together into a single log and see if that helps us. 8 times 1/2 is going to be 4. So we really need log base 3 of 4, and they gave us a number to use for that approximation. So you are supposed to use properties of logs and your knowledge of logs and these approximations to find the answers on number 5. It's on number 6 where it's a reminder. You should know how to use the change of base formula by showing appropriate work. In other words, for example, if you were given log base 15 of 27, then that means that you are meant to take the log of 27 over the log of 15. Or you could take the natural log of 27. Again, each time here, notice my 27 is the higher number. It goes on top. My 15 is the lower number, so we'll put that over the natural log of 15. So any way this is equivalent to this is equivalent to that. So you could put this in your calculator, or you could put this in your calculator. You could use any base that you wanted to here to be able to solve that. So this is just an example of the process you would go through if you were asked to find, use the change of base formula to find log base 15 of 27. Okay, so you need to understand this idea and how to go about using those steps. So now we want to find the inverse of this function. We need to start by, we're going to have to switch places with x and y, but we don't see a y, so we'll rewrite f of x as y. So y equals the natural log of x minus 2. Now I'm going to switch places with x and y. So where I have a y, I'm going to make that an x. And where I have an x, I'm going to rewrite that as a y. So I'm going to put a y where the x was. Just showing those in blue. Thought I would show those in blue, but my blue is not cooperating. I'm just trying to show those in a different color so you see where the change happened. Okay, so now we need to solve for y. The best way to solve for y right now, since it's stuck inside of the argument of a logarithm, is to rewrite this in exponential form. So I have to think about what's my base when I have natural log. Well, e is my base. So I'm going to have e to the x is equal, because here's my exponent, e to the x equals y minus 2. And now all that's left is adding 2 on both sides. And since e to the x and 2 are not like terms, then we will get, let me put my result over here since that's rather small, the space that's left, e to the x plus 2 is equal to y. And now let me rearrange that, put this first, e to the x plus 2. Now we'll change y into f inverse of x is equal to e to the x plus 2. And now we've rewritten, we found the inverse function for number 7.